So what will you learn when you take this course and commit to it? Well, first I want to tell you what cryptography usually feels like when you start doing it. So if you want to use it, usually APIs of crypto libraries are incredibly complex and very, very frustrating to work with because you don't understand what the hell they want from you. Cryptography very often means very hard to understand math, at least for computer scientists, because cryptographic research is usually done by mathematicians, and mathematicians tend to not care if anybody understands what they're doing, especially if they're from outside their own field. Implementations of cryptography are usually highly optimized to the extent where it's also highly unreadable. Very often you have to deal with assembly code and that sort of thing. So very often the implementations are also incomprehensible. So if you don't understand the API and you want to look at the implementation, you just don't understand it. And very often, if you want to find out how secure a system actually is, you find incomprehensible sentences like, well, the CPEG is tightly CPA secure under module WLWE hardness assumptions, which of course if you're new to cryptography doesn't mean absolutely anything to you. So what do we want to teach with this course? Well, we want for you to make the APIs comprehensible by actually understanding what they do. We also want to teach you the basic math required to look up research papers and understand what it says in them, how the cryptography actually works from a theoretic perspective. We want to make implementations comprehensible for you, so you can actually look into implementations and see if you like what you're seeing, if the implementation from your standpoint seems to be correct. And we want to make security claims comprehensible for you, meaning that you can actually look up what a cryptographic primitive claims and what the assumptions are behind these claims. So we want to enable you to choose correct primitives, protocols, and implementations in your projects, and to also assess, to a certain degree, implementations and demand, like what do you actually need, what you don't need, and also to assess security claims and if they make sense for your project. And we want to enable you to choose the correct implementations of primitives and of protocols. Now within this course you will implement a lot of primitives and also protocols, but you will implement them in a functional way, not in a secure way. So the implementation we use is for you to learn how the primitives truly work, not for you to write your own primitives, because there's no need for it. There are quite enough optimized primitives online. So in order to enable you to do those things, to choose, assess, and implement, we'll be teaching you cryptographic primitives, first by the theory behind them and the security claims they come with, and how they are embedded into protocols. Then we will look at how to implement them and how to use them. We will also teach you about cryptographic protocols that use those primitives, and tell you about what kind of security claims these protocols make, what are they secure against and what aren't they secure against, for you to understand definitions of security protocols and to also understand their proofs and the limitations of those proofs. So we want to enable you to choose the right cryptographic tools for any project, to assess the quality of those cryptographic tools in theory, but also looking at the implementation that you want to use. And we want to do all that while keeping it real. So This is a computer science course, and you will be almost exclusively working with code and writing code, because that's the best way for you to understand how these things truly work.